I'm going to project with this PDU. All these are very simple. It's not that tough any mathematics. So now if there were no explosion, it would have just continued its trajectory. If there were no explosion, the explosive water pen would have continued its trajectory and it would have landed at a distance at a range r. What is this r? This r is equal to u square sine 2 theta by g. This would have been the range. No explosion occurs. Okay, somewhere in the mid here we'll take it. Here definitely it will have some velocity, and due to explosion, so what will happen? So it cannot have the same speed. I think you know projectile motion now. So let's analyze like this. So it in mid-air the collision will occur. I'll take help of diagrams, so it'll be easy to express that idea. So mid-air collision will occur. So due to collision, so what will happen to the fragments? The fragments, one fragment, the other fragment will show it. So what are these? These are the fragments. Now what actually happens is one of the fragment will trace out a path like this. Will land here. So will land beyond the launching point. The other fragment where it has to land. In mid-air the collision will occur. And it will break up into two equal fragments. So m by 2. So this will have some velocity, say v1, v2. And what is the trajectory of this? The trajectory of this, it has to be in this way. Where it has to land here. So now let's come for this one. Due to explosion, what are the forces that are acting? They are internal forces. And we know due to internal forces, center of mass will not shift. So now, what is this dotted line? So this will be the trajectory of center of mass, as if the center of mass will move as if there is no explosion. The center of mass will move, it will continue its path, parabolic path. Where do center of mass will go and strike the ground? At a distance r. Means what is this? This one is the path of center of mass. The center of mass will move as if nothing has happened. It will go and strike the ground at a range r. One of the fragment will go and land here. So let this be distance r by 4. Where the other fragment should be, because the center of mass will come and strike here. So now m1 x1 should be equal to m2 x2. So if this is x1, what about the other fragment? Other fragment should be at a distance x2. The diagram may not be up to the scale. m1 x1 equal to m2 x2. So both are of equal mass. So here no. Okay, the other fragment will land here. What is the mass of this? This is m by 2. Masses are same, no? So here m1 x1 equal to m2 x2. This is m by 2 x1 m by 2 x2. So therefore x1 equal to x2. What is x1? We know x1 from the diagram. R by 4 plus r is equal to x1, which is equal to how much? 5r by 4. So from this particular point, at what distance it will be? It will be at a distance of 5r by 4 from the center of mass. From the launch point, it will be different here. So what is this distance now? This x2. x2 we should write it as 5 by 4. From the launch point, if one of the fragment at a distance r by 4, what about the other fragment? The other fragment should be at a distance of r plus 5r by 4. How much it will be? From the launch point, so what is the distance from the launch point to calculate? R plus 5r by 4. like this it is going to land here. So like this, if you know one of the fragment where it lands, we can predict where the other fragment will land. That's one of the sequence. So like if they don't break up into, if they break up into unequal fragments, it can happen. If they break up into unequal fragments, then what conditions will come? I'll go for the next situation. Just analysis, see, just analysis here rather than some. Okay, this is the center of mass of will land here. It is projected with a speed u at an angle theta. Unequal fragments, one of the fragments, somewhere the explosion somewhere will occur here. I'll just show it in this way. Explosion will occur. Then due to that, m by 4 will come and land here. At what distance? Say like a r by 2. What about the other fragment? Where do we expect? And we know this should be the r by 2. If m by 4 will mean, so the heavier fragment will be here. 3m by 4 should be there, no? So can we predict this distance? So now this distance should be the x1. Again, there's a second case. So what is the formula now? m1 x1 equal to m2 x2. So here what is m1? m1 is m by 4 x1 x1 equal to 3x2. So what is x1? x1 we have idea from the diagram, r by 2 plus r by 2 plus, or let it r, 3r by 2. x2 must be 2r. r by 2, sorry. So O will be always, the heavier mass will be near to the center of mass. The heavier mass, suppose it was green color, no? O will be the near to center of mass. The heavier mass will be near to the center of mass. See. So if you know position of one of the fragment, the other fragment where it is, we can predict. If you know the heavier fragment, you can tell where the lighter fragment is. Sir, can it happen like this? Yes. Even instead of falling beyond, it may happen here. If it falls here, then if you know this distance, you can predict the other fragment where it will be. The explosive can break up into two equal parts or unequal parts. It's not that the fragment should be of equal mass. Need not. It can be of different mass also. But what is there? There's a path of center of mass. Though explosion occurred, here explosion, the center of mass will continue its parabolic path. Any reason for that? Due to explosion, the internal forces will act. Internal forces cannot accelerate center of mass. So in what direction the center of mass, because of the projection, how it should move? It will continue to move its in trajectory. Okay, there's no object will move here. Sir, is there any mass will move in this direction? Nothing. Center of mass will move in this trajectory. Parabolic path, it will continue. The other objects, it will go like this. Now what are this red color and this one? This is the trajectory of